Java Network. Java networking, connecting the dots. Java networking involves building applications that can communicate over a network. It's the foundation for many modern applications, from web servers to online games. Core concepts. Sockets, these represent endpoints for communication. There are two types. Server socket, listens for incoming connections on a specified port. Socket, connects to a server on a specific port. TCP/IP, the fundamental protocol suite for Internet communication. TCP, Transmission Control Protocol, reliable, connection-oriented protocol. UDP, User Datagram Protocol, unreliable, connectionless protocol. URL, Uniform Resource Locator, represents a resource on the Internet. URL connection, provides a way to open a communication channel to a specified URL. Key classes in Java.NET package. Socket, creates a socket to connect to a server. Server socket, creates a server socket to listen for incoming connections. Datagram socket, creates a socket for UDP communication. Datagram packet, represents a UDP packet. URL, represents a uniform resource locator. URL connection, opens a communication channel to a specified URL. Basic example, a simple client-server application. Java //server. Import java.io *. Import java.net *. Public class server. Public static void main, string args, throws IO exception. Server socket equals new server socket, 12,345. Socket client socket equals server socket.accept. Buffered reader in equals new buffered reader, new input stream reader, client socket.get input stream. Print writer out equals new print writer, client socket.get output stream, true. String input line. While, input line equals in.read line, equals null. Out.println, server. Received, plus input line. In.close. Out.close. Client socket.close. Server socket.close. / client. Import java.io *. Import java.net *. Public class client. Public static void main, string args, throws IO exception. Socket equals new socket, local host. 12,345. Print writer out equals new print writer, socket.get output stream, true. Buffered reader in equals new buffered reader, new input stream reader, socket.get input stream. Out.println, hello. From client. String response equals in.read line. System.out.println, server responded, plus response. Out.close. In.close. Socket.close. Additional topics. Multithreading for concurrent connections. HTTP and web development. Network security. Advanced protocols like FTP, SMTP, and POP. Java networking and the TCP/IP model. Understanding the TCP/IP model. The TCP/IP model is a simplified version of the OSI model, specifically tailored for Internet communication. It consists of 4 layers. Application layer. Defines how data is formatted and displayed to the user. Protocols, HTTP, FTP, SMTP, DNS, etc. Java classes, URL, URL connection, socket, server socket. Transport layer. Handles end-to-end communication between processes. Protocols, TCP, reliable, connection-oriented, UDP, unreliable, connectionless. Java classes, socket, server socket, datagram socket, datagram packet. Internet layer. Handles routing of packets across networks. Protocol, IP, Internet Protocol. Java classes, INET address. Network interface layer. Handles physical transmission of data. Protocols, Ethernet, Wi-Fi, etc. Java classes, network interface. Mapping Java networking classes to TCP/IP layers. Java class. TCP/IP layer. Description. Socket, server socket. Transport. TCP-based communication. Datagram socket, datagram packet. Transport. UDP-based communication. INET address. Internet. Represents IP addresses. URL, URL connection. Application. For handling web-based resources. Export to sheets. TCP vs UDP. TCP, Transmission Control Protocol. Reliable, connection-oriented. Guarantees delivery of data. Orderly delivery of data. Error checking and retransmission. Suitable for applications like file transfer, email, web browsing. UDP, User Datagram Protocol. Unreliable, connectionless. No guarantee of delivery. No guarantee of order. No error checking or retransmission. Suitable for applications like live streaming, online gaming, where speed is prioritized over reliability. Example, a simple TCP-based client server. Java. //server. Import java.io *. Import java.net *. Public class TCP server. Public static void main, string args, throws IO exception. Server socket equals new server socket, 12,345. Socket client socket equals server socket.accept. Buffered reader in equals new buffered reader, new input stream reader, client socket.get input stream. Print writer out equals new print writer, client socket.get output stream, true. // handle. Client communication. // client. Import java.io *. Import java.net *. Public class TCP client. Public static void main, string args, throws IO exception. Socket equals new socket, local host. 12,345. Print writer out equals new print writer, socket.get output stream, true. Buffered reader in equals new buffered reader, new input stream reader, socket.get input stream. // communicate. With server. Additional considerations. Multithreading, for handling multiple clients concurrently. Security, using encryption and authentication mechanisms. Performance, optimizing network communication for speed and efficiency. Error handling, implementing robust error handling mechanisms. By understanding the TCP/IP model and the corresponding Java classes, you can effectively build network applications in Java. User Datagram Protocol, UDP. User Datagram Protocol, UDP. UDP is a core protocol in the Internet Protocol Suite used for sending messages to other hosts on an IP network. Unlike TCP, UDP is connectionless, meaning it doesn't require a prior connection to be established before data transmission. This makes it faster and more efficient but also less reliable. Key characteristics of UDP. Connectionless, no handshake or connection setup required. Unreliable, packets can be lost, duplicated, or arrive out of order. Lightweight, low overhead compared to TCP. Fast, offers lower latency than TCP. Best effort delivery, no guarantees of packet delivery or order. UDP packet structure. A UDP packet consists of a header and data. Source port, identifies the sending process. Destination port, identifies the receiving process. Length, total length of the UDP packet, including header and data. Checksum, error detection mechanism, optional. Data, the actual data being transmitted. UDP packet structure. UDP use cases. Real-time applications, online gaming, video conferencing, VoIP, voice over IP, where a slight delay is acceptable over lost packets. DNS, domain name system, quick lookups of domain names. Streaming media, live video and audio streaming. Network Management Protocols, SNMP, Simple Network Management Protocol. UDP in Java. Java provides classes for UDP communication. Datagram socket, represents a UDP socket for sending and receiving datagrams. Datagram packet, encapsulates the data to be sent or received. Java. Import java.net *. Import java.io *. Public class UDP client. Public static void main, string args, throws IO exception. Datagram socket ds equals new datagram socket. Byte buff equals hello.getBytes. inet address IP equals inet address.getByname, local host. Datagram packet dp equals new datagram packet, buff, buff.length, IP, 1234. ds.send, dp. ds.close. Challenges with UDP. Unreliability, packets can be lost, making it unsuitable for applications requiring guaranteed delivery. No congestion control, can lead to network congestion. Security concerns, more susceptible to attacks due to lack of connection setup and security mechanisms. When to use UDP. UDP is ideal for applications where speed is critical and some packet loss is acceptable. Real-time delivery is essential. Low overhead is required. Difference between IPv4 and IPv6. IPv4 and IPv6 are the two versions of the Internet Protocol, IP, used to identify devices on a network. While IPv4 has been the standard for decades, the increasing number of Internet-connected devices has necessitated the adoption of IPv6. Key differences. Feature. IPv4. IPv6. Address size. 32 bits. 128 bits. Address space. 4.3 billion addresses. Approximately 3.4 times 10 to the power of 38th addresses. Address format. Dot decimal notation, example 192.168.1.1. Hexadecimal with colons, Example 2001:0DB8:000:000:000:8A2E037:0:7334. Header structure. Complex, variable length. Simpler, fixed length. Security. No built-in security. Built-in security features, IPsec. Auto configuration. Requires DHCP. Supports stateless address auto configuration, SLOC. Fragmentation. Performed by routers. Performed only by the sender. Export to sheets. Why IPv6? The primary reason for developing IPv6 was to address the depletion of IPv4 addresses. With the rapid growth of internet-connected devices, the IPv4 address space was becoming increasingly exhausted. IPv6 offers a vastly larger address space, which can accommodate the growing number of devices. Additionally, IPv6 provides several other advantages over IPv4, including improved security. Built-in security features like IPsec offer enhanced protection against attacks. Simplified header format leads to more efficient packet processing. Enhanced auto configuration reduces reliance on DHCP servers. Transition to IPv6. The transition from IPv4 to IPv6 is a gradual process. Many networks and devices still use IPv4, and it will likely be several years before IPv6 becomes the dominant protocol. However, the move to IPv6 is essential to ensure the continued growth and development of the Internet. Difference between connection-oriented and connection-less services. Connection-oriented services requires a connection setup. Before data transmission, a connection is established between the sender and receiver. Reliable, data is delivered in order and without errors. Guaranteed delivery, if data is lost, it is retransmitted. Flow control, data is sent at a rate that the receiver can handle. Congestion control, prevents network overload. Examples, TCP, Transmission Control Protocol. Connectionless services. No connection setup, data is sent as individual packets without establishing a connection. Unreliable, data may be lost, duplicated, or arrive out of order. No guaranteed delivery, lost packets are not retransmitted. Best effort delivery, data is sent without error checking or flow control. Faster, lower overhead compared to connection-oriented services. Examples, UDP, User Datagram Protocol, IP, Internet Protocol. Key differences. Feature. Connection-oriented. Connectionless. Connection setup. Required. Not required. Reliability. High. Low. Order of delivery. Guaranteed. Not guaranteed. Error checking. Yes. No or minimal. Congestion control. Yes. No. Speed. Slower. Faster. Examples. TCP. UDP, IP. Export to sheets. When to use which. Connection-oriented, suitable for applications that require reliable data transfer, such as email, file transfer, web browsing. Connectionless, suitable for applications that can tolerate some packet loss and prioritize speed, such as real-time streaming, online gaming, DNS. Socket programming in Java. Socket programming is a fundamental aspect of network programming in Java, allowing applications to communicate over a network. It involves creating endpoints, sockets, for two-way communication between programs. Core classes. Server socket, used on the server side to listen for incoming connections. Socket, used on the client side to connect to a server. Basic structure. Server side. Create a server socket object, specifying the port number to listen on. Use the accept method to wait for a client connection. This method blocks until a client connects. Once a connection is established, create a socket object to communicate with the client. Create input and output streams to read and write data. Handle client requests and send responses. Close the socket and input/output streams. Client side. Create a socket object, specifying the server's host name or IP address and port number. Create input and output streams to read and write data. Send data to the server. Read data from the server. Close the socket and input/output streams. Example, simple chat application. Java. // server side. Import java.io *. Import java.net *. Public class server. Public static void main, string args, throws IO exception. Server socket equals new server socket, 12,345. Socket client socket equals server socket.accept. Buffered reader in equals new buffered reader, new input stream reader, client socket.get input stream. Print writer out equals new print writer, client socket.get output stream. True. String input line. While, input line equals in.read line, equals null. System.out.println, client, plus input line. Out.println, server. Echoed, plus input line. In.close. Out.close. Client socket.close. Server socket.close. / client side. Import java.io *. Import java.net *. Public class client. Public static void main, string args, throws IO exception. Socket equals new socket, local host. 12,345. Buffered reader in equals new buffered reader, new input stream reader, socket.get input stream. Print writer out equals new print writer, socket.get output stream. True. Buffered reader stdin equals new buffered reader, new input stream reader, system.in. String user input. While, user input equals stdin.read line, equals null. Out.println, user input. System.out.println, server. Plus in.read line. Out.close. In.close. Socket.close. Key points. TCP-based, socket programming in Java is typically based on TCP, which provides reliable, connection-oriented communication. Streams, data is read and written in streams using input stream and output stream or their buffered variants. Error handling, proper error handling is crucial for robust applications. Multithreading, for handling multiple clients concurrently, consider using threads. Security, implement appropriate security measures to protect data. Additional considerations. UDP, while less common, Java also supports UDP socket programming using datagram socket and datagram packet classes for connectionless communication. Higher level APIs, for web-based applications, consider using higher-level APIs like HTTP or frameworks like Java Surflay or Spring MVC. By understanding these fundamentals, you can build a variety of network applications using Java sockets. Java.NET Server Socket class in Java. The Java.NET Server Socket class is a core component of network programming in Java. It allows you to create server sockets that listen for incoming client connections on a specific port. Key responsibilities. Binding to a port, a server socket object is bound to a particular port number on the local machine. This port acts as the listening address for incoming client connections. Accepting connections, the server listens for incoming connection requests from clients. When a client attempts to connect on the specified port, the server socket object's accept method blocks until a connection is established. Once a connection is established, a new socket object is created representing the communication channel between the server and the client. Constructors. The server socket class provides several constructors for creating server sockets. Server socket creates an unbound server socket. Server socket int port creates a server socket bound to the specified port number. Server socket int port int backlog creates a server socket bound to the specified port number, with a maximum queue length for incoming connection requests. Server socket int port int backlog inet address bind address creates a server socket bound to the specified port number, with a maximum queue length and a specific local IP address to bind to. Example: Java. Import java.io.io exception. Import java.net server socket. Public class simple server. Public static void main, string args, throws IO exception. / create a server socket on port 12345. Server socket equals new server socket, 12345. / wait for a client connection. System.out.println, server listening on port 12345. Socket client socket equals server socket.accept. / handle client communication. / close the connections. Client socket.close. Server socket.close. Important methods. Accept blocks until a client connects and returns a new socket object representing the client connection. Get local port returns the port number on which the server socket is listening. Is closed checks if the server socket is closed. Set so timeout int timeout sets the timeout value in milliseconds for the accept method. Additional points. Once a connection is established using accept, communication with the client happens through the return socket object. You can use input stream and output stream, or their buffered variants, on the socket object to read and write data. By default, the backlog parameter for the constructor specifies the maximum number of pending connection requests that can be queued. Closing the server socket object stops listening for new connections and allows any pending connections to finish the handshake process. URL class in Java. URL stands for Uniform Resource Locator and represents a resource on the World Wide Web. In Java, the java.net.url class encapsulates this information. Components of a URL. Protocol specifies the method of accessing the resource, example HTTP, HTTPS, FTP. Host, the domain name or IP address of the server. Port, the port number on the server, optional. Path, the location of the resource on the server. Query, optional parameters passed to the resource. Fragment, identifies a portion of the resource. Creating a URL object. Java. Import java.net.malformed URL exception. Import java.net.url. Public class URL example. Public static void main, string args, throws malformed URL exception. / creating a URL object. URL equals new URL, https://www.example.com/path/to/resource, param1 equals value 1. / accessing URL components. System.out.println, protocol, plus URL.get protocol. System.out.println, host, plus URL.get host. System.out.println, port, plus URL.get port, / if not specified, returns -1. System.out.println, path, plus URL.get path. System.out.println, query, plus URL.get query. Common methods. Get protocol, returns the protocol part of the URL. Get host, returns the host name or IP address. Get port, returns the port number, or -1 if not specified. Get path, returns the path part of the URL. Get query, returns the query part of the URL. Get file, returns the file name and path combined. Open connection, opens a connection to the URL. Example, opening a connection. Java. Import java.io.bufferedReader. Import java.io.inputStreamReader. Import java.net.url. Import java.net.url connection. Public. Class URL connection example. Public static void main, string args, throws exception. URL equals new URL, https://www.example.com. URL connection equals URL.openConnection. Buffered reader in equals new buffered reader, new input stream reader, connection.get input stream. String input line. While, input line equals in.read line, equals null. System.out.println, input line. In.close. Important considerations. Always handle malformed URL exception when creating a URL object. For secure connections, use HTTPS protocol. Consider using URL connection for more advanced network operations. Handle potential exceptions like I/O exception when working with network connections. By understanding the URL class and its methods, you can effectively handle web resources in your Java applications.